Already take out your notes packet, and we are moving on into section 3 of Mod 9. And we'll start out with our essential question today is, how do I find the area of, and this book calls it composite shapes. Some books call it irregular shapes, or composite figures, I guess I should say. So I will leave it at that, question mark. And then we'd better tackle what on earth does it mean to be a composite figure. All right. If you recall, we have defined the area as the number of square units that it takes to cover some sort of surface. To cover a surface or some sort of two-dimensional thing. I'll just say surface here. All right, composite figure. So you can say it's somewhat of an irregular shape. Basically what it is, though, is it's something that we don't have a name for necessarily, but it's made up of other shapes that we can make sense of and actually have ways to calculate area or perimeter, whatever we're looking for, made up of other known shapes, shall we say. So we could have a bunch of rectangles together, maybe a triangle, square, a circle, all kinds of things. And once we can decompose a composite figure like that, we can calculate area and perimeters and things like that. In this chart, these are a number of the formulas you've used before for area. So I know that you've seen especially like rectangle, parallelogram, triangle. Those ones you've seen for sure in 5th and 6th grade, if not before. So now what we're going to do is tackle this thing right here. I don't even know what you would say this looks like. That's why we don't even give it a name. We just say, hey, it's this irregular shape, and we want to find the area. Now, a generic instruction they give us is use 3.14 for pi. Look at this. Do you see anything circular that has to do with this? In this case, we don't have to use pi because we don't have any kind of circle to worry about. So here's how we're going to tackle this. And they've kind of helped by putting some dashed lines in here. If we can chunk this into different pieces and then just get our grand total for area, it'll be a lot easier. I'm going to just redraw these so it's a little easier to see. This top triangle has sides 2 and 3. I don't care about the slanty side because triangle says take the base times the height and then take half of it. So my base would be 2 and my height is 3, or vice versa. We're going to take 3 times 2. And then we have to take half of it or divide it by 2, which gives me an area of 3. So the triangle has an area of 3. Cool. Look at the next one. You want to do the rectangle? Sure. Let's do that. Now, be careful here, because if you start counting these squares, from here to here is 8, but this whole rectangle goes all the way to here. Sometimes it helps you just kind of re-outline what on earth we're doing so you can see it more clearly. So from here to here is 8, and then you have 3 more. This is 4, so my 11 by 4 rectangle has an area of 44. Then we have this triangle down here. And be careful. At first I thought, oh, I could just put these two together and make one rectangle, but no, this is 3 by 3, so it's a little bit bigger than that one on this side. If you look at it close, I think you can tell that. All right, base times height, and then take half of it, or in other words, divide by 2. 4 1/2 or 4 5/10. So let's add these guys up. My unit is in square feet. And when you add those up, you should get 51.5. Boom. Let's go. Next example. Ooh, look at this one. Aha. So because I have part of a circle here, use 3.14 for pi. Now let's think about what you got. You have this square that's 10 by 10. Cool beans. That's a nice little easy to do in your head because the base times height or length times width or side times side, however you do squares, is just 100. Now, careful here. This is a semicircle, all right? And normally when I do a whole circle, I go pi times r, pi r squared. But this is just half of a circle, so we're going to have to divide this thing by 2. So let's take a look here. I need to find the radius. You could draw it that way. You could go out this way. You could go this way. Those are the easiest ones to count. But frankly, all of these would be exactly the same distance because that's what a radius does. If this whole side is 10, because it's also the side of the square, you should be able to determine that your radius, if my diameter was 10, my radius, ta-da, is 5. So grab your calculator and let's figure out what the area of this thing is. I have to take 3.14 times my radius times the radius again. And then I'm dividing by 2 because I only have half of this circle. All right. When you get that value, which is somewhere 39 something, then add them together to get your final area of the whole thing. All right, we've got 2 more. Let's go. Notice that these are going to take it a little bit further. We have a banquet room that's being carpeted. A floor plan of this room is shown at the right. That's weird. Each unit on this grid represents 1 yard. Okay, 1 yard by 1 yard. The carpet is going to cost $23.50 per square yard. So how much is it going to cost to carpet this room? Ooh, a lot. Okay, they've helped by drawing in these dashed lines, and you can certainly draw this right on the grid as you're looking at it here, but I'm going to separate them to kind of help you think about this as 3 separate pieces. You have the parallelogram, the rectangle, the teeny tiny triangle, okay? Now let's look at your parallelogram. Parallelogram formula, if you flip back to that first page, said base times height. 1, 2, 3, 4. The base is 4. The height is this way. That is 2. The height is 2. So base times height, 4 times 2, 8. You know, you could visualize this one nicely too if you just think of taking that triangle, chopping it off, adding it back on the bottom, and then it turns it into a rectangle. It's a little easier. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Rectangle has an area of 24. Let's look at our teeny tiny triangle here. The base, the bottom there, is 1. The height, it's 2 units high. We have to take 1 times 2, but then divide by 2, which is going to leave us 1. Oops, I'm not quite done. Shoot, see, I was jumping the gun. Erase. So, my area, yes, indeed, is 33 square yards, okay? That's my area. But I am not done with the problem. What we need to do is calculate the cost. So, multiply that 33 square yards by 2350, which is how much it costs each square yard, and that will give you the grand total, which I do believe is $775.50. And in fact, you probably even buy a little bit more just to make sure you're not having to piece a whole bunch of things here. So leave it to the professionals to figure that out, okay? All right, this looks to me like a hockey rink. They're saying this is a unique window, okay? And it's going to be replaced with some tinted glass. So the plan at the right shows the design of the window. I'm going to write it as 3 separate chunks. So we have a semicircle here, rectangle in the middle, semicircle here. Each unit length represents 1 foot. The glass costs $28 per square foot, so how much is it going to cost to replace? Take a look here. This half circle and this half circle, frankly, will come together to be one whole circle plus the rectangle. So we can find the area of this circle if we remember that area is pi times radius times radius. So let's figure out the radius of this circle. When I'm over here, regardless of which way I go, looks like my radius is 2. Pi times 2 times 2, or 3.14 times 2 times 2. And be careful, that's going to give us the whole circle, okay? So we have half here and half here. That makes one whole. Crank that out. 12 and 56/100ths, I believe. And then let's take care of this rectangle in the middle. 1, 2, 3, 4. It's 5 by 1, 2, 3, 4. So that's a nice 20. So when I add these together, I get 32 and 56/100ths square feet. Now, what is that as far as the price when it costs $28 a square foot? Crank that out and it will give you the final price. I believe you get this. All right. So our summary here is, how do you find the area? We are going to break up composite shapes into smaller pieces. And I'll say easier pieces or shapes. And then find the total when you go from there. Cool beans. Alrighty, check Schoology for your assignment. And as always, good luck and may the force be with you.